Hello everyone, welcome to today's class. In this lecture we are going to discuss about different kinds of relation, reflexive, symmetric and transitive. Okay, so let's go through the basic definition first, and then we'll look at the examples to understand those definitions. Remember that this is sort of a theoretical chapter, so you have to understand it. There is mathematics part is very much limited. It's the understanding and the definition, the depth of definition that should be very much clear. Okay, so let's go through the definition first. So any relation is called reflexive if one sec. Yeah, so any relation is called reflexive. It's if AA belongs to R. AA means you should have element of A comma A type. Okay, A will be belonging through the set A. Okay, it will be like let's say A is 1, so 1 comma 1, and if A is 2, so 2 comma 2, 3 comma 3. These kinds of elements should be present. But remember this word here, every means for all elements. Suppose A set is 1, 2, 3. Okay, and you say I have a relation which has let's say 1, 1, 2, 2. Okay, so kind of it is satisfying this, but it is not applicable for all elements of A. It should be for all elements, for 1, 1 also, for 1 also, for 2 also, for 3 also. So unless and until 3 comma 3 is present, I'll say this is not reflexive. Okay, if only 3, 3 was present, then I would have said yes, it is reflexive. Okay, then yes, reflexive. Reflexive. Okay, that's the meaning of this. Only this definition has the word every. Okay, the next type of relation is symmetric. So symmetric relation goes like this. If it is saying if only you have A1 A2 which is in this relation, then you should have A2 A1 also. Means if 1 comma 2 is there as a relation, then 2 comma 1 should also be there. Then only it's called symmetric. Okay, all right, and transitive works like this. If A1 A2 is present and A2 A3 is present, then A1 A3 should also be present. Okay, but both second and third kind of relation doesn't apply for every element of A. They are implied based on the condition that if 1 comma 2 is there, okay, and 2 comma 3 is there, then 1 comma 3 should also be there, something like that. Let's understand them better with the help of examples. Okay, also one more definition. If a relation is reflexive, symmetric and transitive, means all three relations are being satisfied, it is called equivalence relation. Okay, it's an equivalence relation. Now let's see from theoretical aspect what is the meaning of this. So again, theoretical kind of question is saying let T is the set of triangles in a plane, and with R relation given in T by T1 comma T2. How do we read this? T1 comma T2 is the element of this relation defined by such that, this double dot means such that T1 is congruent to T2. All right, he's saying show that it's an equivalence relationship, although you have to be finding this whether this is equivalence or not, but right now its question is giving you this idea that this is symmetric, reflexive as well as transitive. So let's see, the first was symmetric. Okay, so symmetric goes for like AA. Okay, so we have T1 T2 now. So if I say AA means there is a triangle called A. Okay, what I'll do is I'll take help of this. So let's say this is a triangle, and if I copy it and paste another triangle, okay, this is just exact copy of this. Can I say these two triangles are congruent to themselves? Means these two triangles are same, they actually overlap with each other. Means I can say every triangle is congruent to itself. So AA is belonging to this R is correct. Why? Because every triangle is congruent to itself. Now this is what I was talking about, theoretical sense. Math, this is not maths, solving maths. No? This is understanding the definition, that kind of maths. Okay. Second, let's check for, sorry, my bad. I written symmetric na, here. This was actually a reflexive. First is reflexive. Na? Reflexive. Next is symmetric. So symmetric goes like this. A1, if A1, A2, only you need to remember this. If A1, A2 belongs to R, then A2, A1 should also be there. So what is the meaning of A1, A2? Means there are two triangles. A1 which is congruent to triangle A2. Okay. Triangle A1 is congruent to triangle A2. If two triangles are congruent, if A1 is congruent to A2, can I say that triangle A2 is also congruent to triangle A1? And if I can reverse the order, can I say now A2 comma A1 is a relation here? Okay. If A1 comma A2 means A1 is congruent to A2, which automatically implies A2 is also congruent to A1. So can I reverse this also? Okay. Try to understand from the meaning. A1 A2 means A1 is congruent to A2. A2 A1 means A2 is congruent to A1. Both means the same thing. So that means this is also correct. This is symmetric. And last, transitive is saying if A1 A2 belongs to R, means there is a triangle in which triangle A1 is congruent to triangle A2, and if A2 A3 also belongs to R, triangle A2 congruent to triangle A3. Okay. Can I, from these two relations, mark this as 1, mark this as 2, can I say triangle A1 is congruent to triangle A3? From these two conditions we can imply this. That means somehow if they are congruent, I will say this is the relation between them. So I can say A1 A3 definitely belongs to this relation, that they are congruent. The relation is that the triangles have to be congruent. So yes, transitive also. So from in the case of symmetric and transitive, from the relation itself you have to generate A2 A1, and from this you have to generate A1 A3. Given the two conditions are already true, we have to assume that and generate the third one. Okay. Let's understand one more example of this. Okay. So L1 is a set of lines in plane. Okay, so means all lines he is talking about. Relation is defined as yes. So the relation between them is L1 L2 is such that L1 is perpendicular to L2. So if I say L1 L2 means it automatically implies that L1 and L2 are perpendicular. Now let's check it's reflexive or not. Reflexive. Reflexive means A comma A. Okay, so there is a line A which should be perpendicular to A. Does it make any sense? A line is perpendicular to itself. This is a line, okay, and I'm making a copy of it. See, automatically it generates parallel line. It will never generate a line same. If I want to generate the same line, it will generate a parallel line to itself, not a perpendicular line. So this cannot be true. A line cannot be perpendicular to itself. A line can overlap with itself, or I can say a line is parallel to itself, but never. I'm not able to do this because of restriction of the tool, but you get the idea that a line can be parallel to itself but not can be perpendicular to itself. It's not possible. So A comma A cannot be having this relation. Similarly, let's check for symmetric. So symmetric says A1 comma A2. So there are two lines. One is A1, another one is A2, and the relation is that A1 and A2 are perpendicular. So fine. I'm drawing just to make you understand. As such, drawing of lines are not required. So let's say this is line A1, this is line A2. can I say this automatically implies that A2 is also perpendicular to A1, which means somehow A2 A1 is also satisfying this relation if they belongs to R. It implies A1 and A2 are perpendicular, which effectively means A2 is perpendicular to A1, which means A2 A1 is having this relation. Okay, so whether I say L1 is perpendicular to L2 or I say L2 is perpendicular to L1, both are same thing. So that means it is symmetric. Okay, and finally comes your transitive. So transitive, we need to assume two things: A1 A2. If A1 A2 and A2 A3 belongs to R. Okay, so that means A1 is perpendicular to A2 and A2 is perpendicular to A3. Let's draw it to understand slightly better. Let's say this is my line L1, let's A1, let's say this is another line A2, A1, A2, and now I have to draw another perpendicular to A2. So if I draw perpendicular to A2, that's your A3. See, A2 A3 is perpendicular, A1 A2 is perpendicular. What can you say about A1 and A3? A1 is not perpendicular. No. A1 is not perpendicular to A3. In fact, it's actually parallel. So it doesn't belong to A1 A3, does not belong to this relation, does not satisfy this relation, does not belongs to R. So not transitive. Okay. All right. Now for these theoretical sense questions, you have to be good with your thinking. Okay. Now if I give you numbers in this, trust me, it's very easy to judge. Look at this question now. It's the theoretical part that is slightly confusing, but with the numbers, it's always very simple. So a set is given. This is your set A. Relation is also given. Okay. So that's your set A. This is the relation given: 1, 1, 2, 2, 3, 3, 1, 2, 2, 3. Okay, we have to check whether it is, although it is saying show that, so fine. Let's check for reflexive. So for reflexive, what we have to check? A comma A. So what are the elements in this? 1, 2, and 3. See, 1, 1 is present, 2, 2 is present, 3, 3 is present in the relation. So I'll say yes, reflexive. Okay, so for reflexive, we have to check A comma A belongs to R for every A. A means element here. Okay. Then transitive says if 1 comma 2, sorry, symmetric, na? Next is symmetric. Then symmetric says if 1 comma 2 is there, then 2 comma should have been there, but is 2 comma 1 present? No. So if 1 comma 2 belongs to R, then 2 comma 1 should belong to R, but it is not. So therefore not symmetric. And finally your transitive. If 1 comma 2 is there, fine, and 2 comma 3 is there, fine, but is 1 comma 3 present? No, 1 comma 3 is not present, so definitely not transitive also. Okay, so if you have the relations defined like this, 1, 1, 2, 2, 3, 3 in the roster form, it's very easy to understand this, because all you have to do is check for the elements are present or not as per the condition. Let's see next example. All right. It's saying the relation in Z, set Z, means we have to consider integers. Okay. Given by A comma B. So we have to write the elements A comma B as per the condition 2 divides A minus B. Means when you subtract them, it should be divisible by 2. Okay. We can write a lot of numbers which satisfy these conditions because the relation is in set Z. So we'll do in general, not for elements as such. You can do it for elements also. So let's say reflexive. Reflexive says A comma A. Okay. Now A comma A means as such from the definition 2 divides A minus B. Let's So basically we have to check 2 divides a minus a. B is also a as such. So a minus a is 0. So 2 divides 0. It's true. So that means it is reflexive. Okay, that statement makes sense. 0 is divisible by 2, so that's correct. So a is always there. Then check for symmetric. Symmetric is if a1 a2 belongs, so that means 2 divides a1 minus a2. Oh, okay. If we do the reverse, okay, I can say 2 divides negative of, so we have to check now a2 minus a1. So a2 minus a1, let's check for a2 minus a1 belongs to R or not. So a2 minus a1 means 2 should divide a2 minus a1. If I take negative common, this is a1 minus a2. Okay, because we are talking about integers, so negative is allowed. We already know that a1 minus a2 is divisible by 2, na? So negative of that will also be divisible by 2. So yes, it makes sense. Okay. And for transitive part, you have to take a1 a2, then a2 a3. Okay, so it implies a1 minus a2 is divisible by 2. What you can do is, if something is divisible by 2, you can write as 2 into something, 2 into let's say m. And if a2 minus a3 is also divisible, you can write that as 2n also. Okay, you can work that out here also. If you consider it implies a1 minus a2 is some 2m, let's say. Okay, so a2 minus a1 means negative of a this, which implies negative of 2m, and negative of 2m is also divisible by, of course, 2. Clearly 2 is a factor, so still you get the divisibility criteria 2n. Now if we check for a1 a3, so a1 a3 we have to subtract a1 minus a3. Okay, so a1 minus a3, if I subtract these two relation, subtract or add, if I add these two, 1 and 2, if I add them, would I get a1 minus a3? And that will be 2m plus 2n, and clearly if I take 2 common, this is m plus n. A factor of 2 is there, that means definitely it is divisible by 2. So I can say a1 a3 belongs to R. Okay, if you're not comfortable with this, what I suggest, you take any set of integers which satisfy these conditions. Like for reflexive, check 1 1 2 2 3 3, are they satisfying or not? If yes, so yes, reflexive. Sorry, okay. For, and suppose you want to check for symmetric, you take numbers, let's say 2 comma 4. So yeah, or you take 4 comma 2, 4 comma 2 na. So 4 comma 2 divides 4 minus 2 is divisible by 2. Now you check 2 comma 4 will satisfy this relation or not. 2 minus 4 is still divisible by 2. So yes, they are being satisfied. And if you want to check for the transitive, so 4 comma 2 is there, 2 comma 4 is there. So will 4 comma 4 will be there or not? A1 a2 a2 a3, like this. Or you can take any set of integers which satisfy. Your call. Okay. Sometimes you have to generate the relations, so I'll show you few questions in which you have to generate the relation, and then accordingly you have to solve. Look at this question. Relation is defined such that 3x minus y should be 0. So basically y should be 3x, and both is defined in the set 1 to 13. That means the value of x and y should be from these values only. Okay. If I draw this, something you can recall from the grade 11th relations. Okay, I used to draw this now. This is the value of x, this is the value of y, and there is a relation between them now. 1 2 3 up to 14. Similarly 1 2 3 up to 14, and we have to link up the elements which satisfy this. So if I put x as 1, okay, what do I get? Y as 3. If I put x as 2, I get y as 6. For 3, no sorry, 3x now, so 2 6, 3 will get 9, 4 will get 12, and 5 we should get 15, but the problem is 15 is not present in this. Okay, it's only from 1 to 14 now. So I got the elements as 1 comma 3, 2 comma 6, 3 comma 9, 4 comma 12. Okay, you can do either from this or writing like this also. And now tell me whether it is reflexive or not. Is it reflexive? Is it transitive? This is what you have to judge. Okay. So first one, clearly not reflexive, because 1 1 2 2 3 3 they are not present. A comma a should be present now. So 1 1 2 2 3 3 4 4 all should be present. So reflexive, no. Symmetric, 1 comma 3 is there. Is 3 comma 1 present? No. 3 comma 9 is there, so not even symmetric also. Transitive, see 1 comma 3 is there, 3 comma 9 is there. Is 1 comma 9 present? No. Okay, a1 a2, a2 a3, a1 a3 is not present. Okay, so after writing this you can judge. Next, let's see. This time the relation is in set of natural numbers, but there is a condition that x should be less than 4. So the elements of x should be less than 4. That means 1 2 3, and there is only restriction, I think, only on x. So there is no restriction of y. Y belongs to set of all natural numbers. Okay, but the condition is y equal to x plus 5. So for 1, if x is 1, y will be 6. For this it will be 7. For this it will be 8, and that's it, because there is a restriction. Natural number starts from 1, so we cannot have any other relations. So 1 comma 6, 2 comma 7, 3 comma 8. Now you look at this and tell me, what is this? Reflexive, 1 1 2 2 3 3, nothing present. No. Symmetric, 1 comma 6 is there, 6 comma 1 is not there. Not. Transitive, would we say this is transitive? No. Transitive is also not there. There is no cell elements which is satisfying 1 comma 6 then 6 comma something. No, there is no present, so not even transitive. All right. Next question. Another relation. This time he is saying set is defined from 1 to 6, 1 2 3 4 5 6. So this relation is defined in set A, means both x and y should be 1 2 3 4 5 6. And now you have to join the relation x comma y such that y is divisible by x. Okay, so let's say x is 1. So which numbers are divisible by 1? Okay, I think from diagram it will be very tricky. So 1 is also divisible by 1. Okay, so we have to see for which number is divisible, x and this is y. So 1 is also divisible by 1, 2 is also divisible by 1, 3 is also divisible by 1, 4, 5, 6. Okay. So 1, 1, 1, 2, 1, 3, 1, 4, 1 5 1 6. Okay, I think from diagram I'm getting that idea that this will be way too complex. Okay, then x equal to 2. Okay, so which numbers are divisible by 2? So from 2, if I have to generate relation, so from 2 is divisible by 2, 4 and 6. Okay, so 2 comma 2, 2 comma 4, 2 comma 6. Okay, now if we take x as 3, which numbers are divisible by 3? 3 and 6. So 3 comma 3, 3 comma 6. Okay, 3 is numbers divisible by 3 is 3 and 6. So again, if I draw this, it will be very complex, so it's better to write like this. If x is 4, which number is divisible by 4? So only 4, so 4 comma 4. Same with 5 also. So only 5 is divisible by 5 in this set. And if you take 6, so 6 comma 6. So these are all the relations that satisfy this condition, y is divisible by x. Now tell me, is it reflexive? 1 1, 2 2, 3 3, 4 4, 5 5, 6 6, everything is present. So reflexive, yes. Symmetric, let's see, 1 comma 2 is there. Is 2 comma 1 is there? No. And transitive, 1 comma 2 is there, 2 comma 4 is there, 1 comma 4 is there, 1 comma 4 is there. Okay, 1 comma 2, 2 comma 4, 1 comma 4, 1 comma 3, 3 comma 6, 1 comma 6, that is also satisfied. So yes, transitive also. Okay, so third one is reflexive but not symmetric but transitive. Next, let's see. Next, let's see. R is a relation in set Z where all integers are defined like this. So this time he's talking about integers. So as such, x and y will be infinite sets. Okay. So judging the numbers will be like infinite combinations. So he's talking about checking again the reflexive, symmetric, transitive, and the relation is x minus y is an integer. So let's check. Transitive means, sorry, reflexive means a comma a. A comma a means a minus a. Is a minus a 0? 0 is integer. So yes. A minus a is 0. 0 is an integer. So yes, reflexive. Transitive, a1 comma a2. So a1 comma a2 means a1 minus a2 is an integer. So even if I take negative out, it is a2 minus a1, and if I take negative on the other side, a2 minus a1 is negative of the integer. What is negative of an integer? Okay, I'll give you one example. Let's say if I take 1 and 2, so 1 minus 2 is minus 1, integer. And even if I do 2 minus 1, that's 1, it's also an integer. So even if I do negative of an integer, that's still an integer. Okay, negative of an integer is an integer, so therefore a2 a1 is also in this relation. So transitive, symmetric also. Transitive, for transitive take any combination. I think not necessarily again you have to deal in these terms. You can think of any other combination. Again, let's say a1 a2, a2 a3, they all belongs to this relation. So a1 minus a2 is, let's say, I1, and a2 minus a3 is, let's say, I2. If I add them, a1 a2 cancels, so a1 minus a3 is I1 plus I3 I2. Two integers, when you add them, you get another integer effectively. That means a1 a3 also belongs to this relation. So transitive also. Or you take any other combination, 1 2, 2 3. So 1 comma 2 is 1 minus 2 is an integer, 2 minus 3 is also integer. Is 1 comma 3, is 1 minus 3 an integer? Yes. So you can think from the numbers also, you can think from in terms of variable also. All right. I think that pretty much is okay to judge now. Okay, look at this question. It has mod, no? So when the relation is somehow combined with mod, it looks ugly, but the question has same idea. You have to generate elements which satisfy the relation. So although it is saying it's a relation in set A where x belongs to z, but it is applying the condition that x should be more than or equal to 0, less than equal to 12. So basically if I draw it, it will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Should have written the number first. I think I have the ellipse. Should have drawn like this. Much better. Next time onwards I will be using this. Let's use this. What is this? Better. 0, 1. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. Is saying a minus b mod is a multiple of 4. What are multiples of 4 first of all? So he'll say 4, 8, 12. We don't have to go beyond that. Okay. That's it. But remember 0 is also a multiple of 4. 4 into 0 is 0. So we have to consider that also. Okay. Now you have to pick the numbers which satisfy the relation that the subtraction, whether you do a minus b or b minus a, should result in 0, 4, 8, 12. Okay. So let's take the numbers starting from 0. If first of all for 0 the numbers should be equal, that means 1, 1, 2, 2, 3, 3 up to 12, 12 will be there, because if we subtract them definitely they are multiple of 4. Okay. So all these relations are being satisfied here. Okay. All right. Next check mod is there, one is this. Then let's check for 4, the elements which whose difference is 4 and they said they are multiple of 4 also. Okay, multiple of 4 means basically 4 here. So if I take let's say 0, 4. Okay, so 0 minus 4 is 4. Modulus is there, is a multiple of 4. And since mod is there, so I can take them in any order. Okay, 4, 0, 0, 4. Okay, then 5, 1. So I have to take 1, 5 also, because mod is there. So whenever, even if I do 1 minus 5, that's minus 4, whose negative is plus 4. So it's a multiple of 4. Okay, so 0, 0, 0, 4, 5, 1, 6, 2, 2, 6, 3, just keep adding 4. So 3, 7, 7, 3, 4, 8, 8 4, 9 1 2 3 4, now 5 3, sorry, 5 9 9 5, okay, and 6 10 10 comma 6 11, no 7 7 comma 11 11 comma 7, so reverse also, and 8 comma 12 12 comma 8. I'm writing all the elements to make you understand. All you can think is that the symmetry is there, na? Point is, the moment I write this, I know there's a symmetry going on. 1 comma 5, so 5 comma 1 is also there because of this mod. So definitely by writing this, the first two combinations effectively, you are clearly seeing that definitely they are reflexive as well as symmetric. Okay. And for transitive, if you want to judge, do we have the elements here? 1 comma 5, 5 comma 9. See, 1 comma 5 is there. This one, 1 comma 5 is there. 5 comma 9 is there. Now we have to see if 1 comma 9 is present or not. Right now we have written only for the multiples of 4, whose multiple was actually, the difference was 4 only, na? So multiple of 4, 8 is also there. So if I start with 0 8, so 8 0 will also be there. Okay. And if I start with 1 9, 9 1 also be there. So you see 1 comma 5, 5 comma 9, 1 comma 9 is present, so definitely transitive also. Okay. Just by guessing the elements, you can pretty much judge whether the reflexive, symmetric, transitive is working or not. We can keep on going and verify the others also. Okay. I think I forgot one element. 0 0 is also there. 0 0 is also there. So 1 1 2 2 3 3 12 12 up to 0 0 reflexive. Definitely we can say. You have already seen that we were writing 4 0 0 4. So reflexive is there, symmetric is there, transitive I have shown you. You don't have to literally write all the elements as such to understand that. Okay. But if you want to avoid writing all the elements, what you can do is a minus b mod is multiple of 4, na? So what you can do is you can say that a minus b is equal to 4n, or b minus a is also 4n. Mod is there, so we have to consider a minus b as well as b minus a. Okay. But then again, dealing with variables is sometimes tricky. So I think judging any question, whether it is reflexive, transitive, from elements is very simple. So use this rather than this. All right. Okay. Let's deal with an MCQ question. 2 questions I have. Very easy questions. All right, the relation is given to you in this form. He's saying choose whether it is reflexive, symmetric, transitive. You have to choose the correct statement, or if they all satisfy this. So 1 1 is there, 2 2 is there, 3 3 is there. So reflexive, yes. 1 2 is there. That's it. 2 1 is not present. If 1 2 is present, 2 1 should have been present. So even if one condition is not satisfied, it is not symmetric. So reflexive but not symmetric. So symmetric so far no. Transitive. 1 comma 3 is there. 3 comma 2 is there. 1 comma 2 is there. Okay. For reflexive, this is the example. 1 3 3 2 1 2. So yes, transitive is there. So reflexive is transitive but not symmetric. Option B. Okay. Choose the next one. Let R is a relation given something like this. A comma B is the element. A is B minus 6 and B has to be greater than 6. Okay, so choose which is this correct. So we have to just check if this satisfies this equation or not. A is B minus 2, so 4 minus 2 is 2, fine, but point is B has to be greater than 2. See, you have to check both the conditions. Let me erase it. You have to make sure that this relation is satisfied and B should be greater than 6. So here B is not greater than 6. This cannot be element. This and this can be, because at least the B element is greater than 6. So for 8 minus 2 is 6 actually. So 6 comma 8 should have been the element. I think the rest is pretty easy to neglect now. Okay. Remember that this does satisfy. Okay, like 2 is equal to 4 minus 2 is satisfied, but this is not the correct answer. Why? Because the question says B should be greater than 6, so B cannot be 4. All right, I think we're done with the symmetric, transitive, and reflexive. That's it. Okay. That should give you pretty much good idea how to judge the functions are symmetric, reflexive, and transitive or not. Okay. All right. That's it for this lecture. See you in the next class. Good day, everyone.